Hello, everybody, and welcome to our session on navigating the unknowable, creating resilience with security chaos engineering. We are so happy to be here today. We want to thank RSA for highlighting our work within resilience and security chaos engineering and for having us be a part of their RSA 365 virtual series. It is truly, truly an honor. My name is Jamie Dickin, and I am the manager of applied security at Cardinal Health. I lead a team that's focused on continuous security validation and security chaos engineering. And my co speaker today is the one and only Aaron Reinhardt. He is the CTO of Verica. He is one of the pioneers of security chaos engineering. He was the leader of Chaos Slinger back at United Health Group, and he is actually the co author of an O'Reilly report on security chaos engineering. Like I said, we are just so excited to be here, and we have an awesome talk lined up for you today. We're going to share how we believe that security chaos engineering is actually the solution to a lot of the engineering challenges we've had over the past couple of decades. We will also give you some real world examples of how we leverage security chaos engineering at our companies and tell you how you can go ahead and get started as well. So, whatever your area of expertise, I think it's safe to say that we can all align on one basic truth, and that's that system engineering is messy. So, in the beginning, we start with these beautifully simplistic representations of either what we want to build or what we think that we did build. But it doesn't take long for us to sour on those initially perfect creations. And it's not always our fault. It's just that complexity has a way of sneaking into our system. And as time goes on, our problems seem to compound. And we get to the point where we recognize that what we're doing is fighting battle after battle. And what we need is a new radical way to secure and stabilize our systems if we ever want to get ahead of this. The problem that we've been facing is that the old school approach to both security and site reliability was that it was design oriented. And so, in theory, if you wanted to assess a system, you would go and you would take a look at things like single points of failure. You'd pull up your infrastructure diagrams and identify where could latency possibly occur, what different components can interact with each other. But we all know that there are inherent problems with that. So think about, first of all, when is this documentation created? If it's created prior to a deployment, then our documentation might not even reflect the system that went into production. If the documentation was created afterwards, it's still dependent on the lens of the person who created that documentation and the memory that they have. Then you got to figure, is it updated? And if it's updated, does it still show every point of integration? Does it show all of the downstream effects? The challenge that we have is that no matter how we approach this, our process fails because it assumes that the documented representation of the system is actually correct. And I'm sure that a lot of us as engineers have seen plenty of times where that assumption doesn't hold. If your process of a system if your process of evaluating a system rather is dependent on just an outdated or a flat out incorrect representation of the system, whether you misremember it or you didn't know all of the details from a start, your evaluation of that system is ultimately going to fail. And there are going to be plenty of problems that you don't anticipate. It was complexity scientist David Snowden who told us that it's actually impossible for a human to model, document, or diagram a complex system. The only way to understand it is to actually interact with it. So then the answer really is not to rely on our own recollection of our systems, but rather to learn from them and to use empirical data. And that's really what the heart of chaos engineering is, implementing experiments that clearly remind us what our real system landscapes look like so that we can start to tease out those false assumptions. So, Aaron, I'm going to turn it over to you to tell us how to do things differently.
Thanks, Jamie. So really, it's about evolving towards a new approach of learning. And the new approach to learning is one that moves us away from a process of continuously fixing and responding. So when you're constantly in a war room or responding to an active incident, those are not good opportunities to learn. People are worried about being blamed, named, or shamed. It's not a good opportunity to learn. But chaos engineering and security chaos engineering are a proactive exercise where there is no incident, no war room going on. We're able to learn with eyes wide open. So this begs the question that how does a system become stable? So early on in my journey with security chaos engineering, I ran into one of the world's largest payment processing companies. And this engineer was describing a situation where their legacy flagship application, it was an application that ran all of the payment transactions for the large payment processing company. They felt the engineers were confident. They understood how the system operated well. It rarely had an incident or an outage. And they went, for scalability reasons, they needed to move it over to Kubernetes. And they were concerned about this transition and the lack of stability of Kubernetes. Well, I started thinking to myself, was that legacy system always stable? How did it become stable? Well, it became stable, and the engineers became confident and competent through a series of unforeseen events. They learned about what the difference was between how they believed the system worked and how it actually worked in reality through a series of unforeseen events. Unfortunately, learning through that process encounters customer pain. So with chaos engineering and security chaos engineering, we're trying to be proactive, surface the difference between what we believe our system is and how it functions in reality before it manifests into customer pain. So it's also important, like I described before, is people are in a different cognitive space when a incident or outage occurs, especially security outage or incidents, is that people are worried about being blamed, named, and shamed. And people are worried about losing their jobs because, let's be honest, it's not about what happened. It's about get that thing back up and running. We're losing money, and that's not a good learning environment. So chaos engineering, where it fits in the world of instrumentation, somewhat of a loose definition, but folks in the space like to break it, the instrumentation down as the testing and experimentation. So testing would be the verification or validation of something we know to already be true or false. In our world in security, it's more like a CVE, an attack pattern, something we already kind of know and we can instrument for. Whereas experimentation, we're trying to drive new information about that we didn't have before, meaning about the unknown unknowns of the system. And we do that in the form of, I believe if X occurs on my system, Y is the planned result. We never do a chaos experiment we know is going to fail. We only do one we think is going to be true. Because if you know it's going to fail, just fix it, because you're not going to learn anything new. Chaos engineering. So my definition of chaos engineering is that it's the technique of proactively introducing turbulent conditions into a distributed system to try to determine the conditions by which the system will fail before it actually fails. It's a proactive exercise. Security chaos engineering, newsflash, it's not a whole lot different. Really, the security bits are just really more in tune with the use cases and the value in terms of the engineering aspects of security we're attempting to instrument. So one of the goals, the derivatives we're trying to achieve is we're trying to understand where are the gaps, are the low-hanging fruit that allow malicious activity to be successful to begin with before an adversary has a chance to take advantage of them. And the reason why this is so big and so important is a lot of malicious code and malicious activity out there would never be successful if there weren't the accidents and mistakes we make as a normal byproduct of building things. Accidents, mistakes happen, especially with the size, scale, speed, and complexity of modern microservice architectures running in a public cloud. It's just we've never dealt with the speed and complexity post deployment that we have now. And opportunity for as accidents, mistakes increases, what we're trying to do is proactively inject those failures into the system, determine whether or not we are prepared and can detect those things before an adversary can actually utilize them and take advantage of them. So through this process, really one of the goals that we're trying to achieve is we're trying to reduce the amount of uncertainty and the assumptions we have inherently in the system through building confidence, through good instrumentation and data. As engineers, we don't believe in two things. We don't believe in hope and we don't believe in luck, right? It either works or it doesn't. And we believe in instrumentation and data. And we're trying to instrument and build empirical data that shows us whether or not our system works as it's supposed to. And that helps us build confidence. So here's some security chaos engineering use cases. There are more use cases documented in the Security Chaos Engineering O'Reilly report, as well as in the Chaos Engineering O'Reilly book. But a few use cases you can get started in using them. Chaos engineering for security on are incident response. Security control validation is a great one. Also, I really like security observability. It's a great way to understand how well you can understand what's happening inside of the system, especially the system security, through the kind of outputs you get from it, the log events, the alerts. And because we're proactive, we're not worried about an incident or an outage and trying to chase that down. We're able to kind of determine, wow, this log data made no sense. This control is not saying the right information for me to make a determinable decision on what to do here. And lastly, compliance. Compliance is a great, every chaos engineering experiment, whether security or availability stability based, has compliance value. Essentially, you're proving whether the technology worked the way you had it documented or the way you thought it did. And all that has auditable value.
There are a handful of companies that are implementing security chaos engineering today, and we are already seeing that number increase, which is fantastic and just tremendously exciting to us. Cardinal Health, where I work, was one of the first to really begin implementing that discipline, and we started in the summer of last year. Of the use cases that Aaron just described, the one that really drove our adoption was security control validation. At the end of the day, we, like so many other companies, put our faith in the idea that the tools, the technical designs, and technology standards that we have keep us secure. And it's not that we don't trust our people, but look at the data. So in the infamous 2020 cost of a data breach report, a lot of people regard that the key takeaway is that 52% of data breaches are caused by malicious actors. And really, these numbers have not changed in the last 10 years. But while that's what a lot of people take away from this, what I take away is that there's actually still 48% of data breaches that are caused by mistakes and accidents. And to me, these are preventable failures and the ones that my team targets. Our leadership at Cardinal Health realized that we needed a different approach to security, one that focused both on building security controls, but also validating that the ones that we had stayed in place and didn't degrade over time. And really, we wanted a way to get after that 48%, which we believed was preventable. So last summer was when we really invested in a team to fix this and to really start something new. And we first started, I came from a career in software development, but we started to see what are some of the other key skill sets that we wanted to have on this team. And really the fact that we were building a multidisciplinary team, we viewed as key to our success. So on my team, I have somebody who knows a lot about network security. I have somebody who knows architecture. I have somebody who is a former systems engineer themselves, and then somebody from the risk and the privacy space. But as I so delicately put it, one of the things that we want to do is have people with good hypotheses on where some of the skeletons in the closet are buried, so that we can make good hypotheses on where to look first and how to address some of these concerns. Next, a lot of times we do build a lot of our own validations using our own custom scripts and APIs from our platforms. But other times we do take a look and we see what else is out there, whether that's open source solutions that already exist or commercial technologies, if that's more important. But ultimately, at the end of the day, our goal is to identify these unknown technical security gaps and partner with the organization to remediate them before a bad guy finds them for us. So, how exactly do we do that? So, as excited to just go nuts and get access to every system and every project and look for technical security gaps, we knew that we really needed a disciplined and a repeatable process to do this. And we identified three key goals. So, first was that our process had to identify indisputable critical security gaps that, when the organization considered the risk, we agreed it was worth fixing. Otherwise, you don't need somebody just pointing out a whole bunch of things, but then ultimately doing nothing with the data. So, what we had to do is we knew we had to establish benchmarks, ones that were relevant to our company and relevant to our systems. They couldn't just be theoretical best practices that people considered to be too lofty to achieve. They needed to be things that the organization agreed we had to fix. Second is that our process had to be able to be big enough to see the big picture of a technical security gap. Whereas our previous frontlines engineers had either seen evidence of gaps in the past or they had hypotheses, what they lacked was the detail to be able to describe where this was, what the risk to the organization was, and really drive it to remediation. And so we wanted to be the answer to that challenge. And then finally, we needed to make sure that any gap that we identified and drove to completion wasn't just unknowingly reintroduced in the future. So, with these goals in mind, we created a process called continuous verification and validation. And simply put, we wanted to, on a regular basis, continuously verify that our controls were where we believed that they were supposed to be and validate that they were implemented correctly. And this process to us has 5 main steps. First is obviously you need to understand which control you're validating. And then you need to understand what are the benchmarks that we're going to assess this control by. So, largely to give authority to the benchmarks that we're using, we like to use the patterns and the standards that are set forth by our security architecture team and are approved by our CISO. But if those don't exist because it's a brand new area that we're looking at, that's where we will start to make some of our own recommendations, socialize those recommendations with the relevant teams, and get that buy-in so that, again, like I was saying before, we wanted to make sure that if we identify something, we agree that it has to be fixed. The next is where we get to do the fun part, and this is really where security chaos engineering comes in. And that's where we build the automation to validate those standards. Again, we could be writing our own scripts, we could be using technologies, but we need to learn what our systems actually look like. Next, we start to create dashboards to show the real picture of that technical security gap. And this does 2 things. So one is it gives us that real-time visibility into how we're doing with our security posture. But it's also a really good tool when we talk to our leaders and when we're talking to partner teams to help drive these remediations. And then finally, if we start to see that our adherence to those benchmarks decreases, that's where we create an issue in our risk register, and we have a governance process to drive that through remediation. So that right there is the Cardinal Health story. So Aaron, I'm going to turn it over to you to talk about your work with Chaos Slinger.
Thank you, JB. So about 4.5 years ago, I started this journey on United Health Group. I was the chief security architect of the company. And so we ended up writing this open source tool called Chaos Slinger. And I'm going to talk about the primary example of Chaos Slinger. So when we open sourced it, really we created this tool to really be a methodology for verifying and validating that the security we were building in the cloud, AWS at the time, we're undergoing the AWS cloud transformation. We're trying to determine that, hey, all these decisions we were making were good decisions and they were functional and effective decisions in that as well. And so in the process of open sourcing it, we needed a good example the rest of the world could understand from an experiment perspective. So the example that we open sourced was something we called PortSlinger, which was the injection of a misconfigured or unauthorized port change. For some odd reason, it still happens all the time in the cloud, in the data center, what have you. So anyway, it was a good example, whether you're a software engineer, whether you're a network engineer, a firewall engineer, or doesn't matter. Everybody kind of understands what a firewall is supposed to do and what a sort of a basic understanding of network. Well, some of the reasons why a unauthorized or misconfigured port change could happen is one, obviously the change could be applied incorrectly. Somebody could have made the change out of band. Somebody could have filled out a ticket incorrectly. Lots of reasons why somebody could have misunderstood flow, for example. Lots of reasons why that happens. Well, anyway, so our assumption is that we've been solving for this kind of problem for 20 years, right? 20 plus years. So so our assumption was our firewalls in AWS would immediately detect and block this kind of issue, and it wouldn't be a non-issue. So what we did was we wrote this little chaos slinger with this experiment, and we started injecting that in our AWS EC2 security groups. What we started finding out was that was not always the case. What we found out is about 60% of the time, our firewalls caught it and blocked it. But our expectation was 100% of the time that would happen. The issue was it was a drift issue between our commercial and our non-commercial environments. So this was proactive. Remember, we were able to fix that, and it was a non-issue. But so that was the first thing we learned. The second thing we learned was the cloud-native configuration management tool that we were using caught it and blocked the change every time. So something we were barely planning for, kind of was catching it and blocking it every time. This is the second thing we learned. The third thing we learned was at the time we didn't really use a SIEM. We used a sort of our own homegrown sort of security logging and monitoring solution. And we were expecting, I had a little faith that the alert was actually going to be generated from the events because the log events were sent from the configuration management tool and the firewall tool that should correlate an alert, right? Well, that actually happened. So that was great. We built confidence that our homegrown solution was actually throwing the right alerts. So that was the third thing we learned. The fourth thing we learned is when the alert got to the Security Operations Center, the SOC analysts did not know what to do. They couldn't determine which AWS account structure it came from because we have a lot of we have both non-commercial and commercial. And as an engineer, you can say I can map back the IP address to figure out where that came from. That's right. It could take 15 minutes, 30 minutes, up to 3 hours. If SNAT is in play, it's going to take a lot longer because SNAT hides the real IP address. Well, the point here was that had that actually been an outage or an incident, that would United Health Group loses millions of dollars when they're down. But there was no outage, there was no incident. All we had to do was add metadata to that event, and we have fixed the problem. And that kind of illustrates sort of how we're able to test an instrument part of the chain. And then the idea is once you prove your chaos experiment is successful, it becomes more of a regression test. And you run it more over time periodically.
Thanks, Aaron, for that. So if you're looking to get started with security chaos engineering and you need more of a foundation before you implement, the great news is that there's now an official O'Reilly report on the topic, and it's free. So it was written both by Aaron and by Kelly Shortridge, who is the VP of Product Strategy at Capsule 8. And it contains a whole bunch of stories for people who are doing this in the real world. So, for example, if you've enjoyed the conversation a little bit about Cardinal Health and you want to learn more, I go into much more detail in that report. And we have people from across the globe who have done this at their companies as well, including Verica, where Aaron works, Google, Capital One, and others. I really can't say enough good things about this book because it does contain so many just real world examples. So please, please, please do check that out. Next, if you're thinking that security chaos engineering is just too cutting edge for your organization, this is where I really encourage you to adjust your mindset and think of this really just like standard testing. As I said in the beginning, my background's actually in software development. And what really attracted me to security chaos engineering was that the parallels between this and software testing were just too profound to ignore. It's just that instead of testing that your system meets the functional requirements that were set forth, you're testing that your system's meeting not only the security requirements, but the resilience requirements as well. And you can do things like the use cases are really super similar. So you can run this in a non-prod environment that's awaiting promotion to production to make sure that you haven't done any unknown damage. You can even look at this like where my team wants to go, which is taking a look at this like it's test driven development. So, where we really want to be is we want to start partnering with our security architecture team and others that as our company is developing new patterns and new standards, we're writing our tests up front. And as those new controls are built, we see our tests start to pass to know that we are deploying a new security control in the way that we think is best for our company. So when you think about it that way, security chaos engineering really stops being just so esoteric and really becomes logical. As I see it, just as the world as software engineering and systems engineering first adopted testing methodologies, really the rest of the systems engineering world is going to do the same. And the good news is that once you've gotten past that mindset barrier and you're ready to experiment, it's possible to start very, very small. I think one of the myths of security chaos engineering is that before you can do anything, you have to have this massive systems wide experiment in production that takes you multiple weeks to build, requires VP approval and everything. But that doesn't have to be the case. So if you take a look at the example that Aaron had just shared, really what I see here, it's the opportunity for multiple tests. So instead of doing all of this at once and recreating PortSlinger in your environment, you can start to do things like test maybe just the fact, did you receive that log message when something was changed? You could even do that manually. You could do something in a non-production environment or safely in a production one and verify that you get a log message. Similarly, if a log message is recorded, you could just test the incident response portion. And what this allows you to do is you can start to get a couple of your examples and then organically grow the business case to do more concerted efforts with security chaos engineering and security control validation. So if you're wondering where to begin, you may have a few high value, low effort targets in mind, and that's awesome. And you can start there. Like I said, I guarantee you'll be able to prove your value pretty quickly and organically grow that case for sustained investment. But if you're like me, maybe you have a lot of discrete high value testing possibilities and it's hard to make sense of them all. In this case, to me, it's okay for you to be what I call the right kind of lazy and be a little selfish. So start to look at the health of your team. Like, do you have engineers who log into your systems every day just to make sure that services are up and running? Worse, do they do this on the weekends or in off hours? When you are that right kind of lazy, you start to put the engineering effort up front to be able to build some simple validations and some simple tests that will push alerts to you when something fails. And in this case, to me, this is the beauty of security chaos engineering because it allows you to start building confidence that your security is working even when you aren't. And so there you have it. As you can see, security chaos engineering is a field that it seems so esoteric and out there, but really at its core, it's just incredibly simple. Instead of allowing the complexity of our systems to overwhelm us and cause so many opportunities for mistakes and accidents, the solution is to really flip that model on its head. Instead of relying on our outdated documentation and our preconceived notions, and instead of relying on our production incidents to teach us about our systems, we can proactively go in, eyes wide open, ready to experiment in a time of calm and actually learn about our systems. And when we do this, we actually get the opportunity, and I do see it as an opportunity to remember our systems for what they are and not what we hope for them to be. And it's through testing and experimentation that we get the opportunity to identify ways for us to proactively secure and stabilize our systems and get ourselves out of the reactionary fire drill engineering practices of today. And there you have it. We hope that this session was valuable and that you learned something. Again, major thanks to the organizers of RSA for putting this together and for highlighting us and our work in both resilience and security chaos engineering. We were incredibly excited to be a part of the 365 virtual series. And a few things to keep note. One, if you are looking to learn more, there is a link at the bottom of this slide that's not only going to get you a free copy of the Security Chaos Engineering Report, but it's also going to get you a copy of the official O'Reilly book on chaos engineering as well. So both books are incredibly awesome. Make sure to check those out. And again, they are absolutely free. Next, we are going to be continuing this conversation in a live Q&A session if you're joining us here today. So we are so excited to be able to go a little bit more behind the scenes, talk about our stories and answer whatever questions you have. And of course, we've provided our contact information if you'd like to continue the conversation there. Thank you for everything.